Hi guys, today we're going to talk about matrix multiplication. So we're going to look at two matrices and multiply them, and then we'll tie up the operations with addition, maybe subtraction and multiplication. So the question is, what's so special about the product of A and B? So let's just say we have a matrix given by A with dimensions MP. And then we have another matrix named B with dimensions P by N. Okay, the question is, what will be the dimensions of the product AB? First of all, for matrix multiplication, we can't just multiply any two matrices at random. We need to make sure we meet a certain criteria. We need to make sure that the columns of the first matrix is the same as the, I said it wrong. We need to make sure that the, oh, I said it right, sorry. We need to make sure that the columns of the first matrix is equal to the number of rows of the second matrix. And if so, then the dimensions of the product will be given by the outskirts of these dimensions. So it will be given by M by N. So that's like a lot of information. So suppose we were asked to list the dimensions of the product AB. So matrix A is a 2 by 2 matrix. Matrix B is a 2 by 4 matrix. So I want to know, is the product actually defined? I don't know. So the reason why I had a moment over here is because I don't really think about columns of the first should equal rows of the second. I just list the dimensions side by side, and I ask myself, are the insides the same? Cool. If the insides are the same, then the product is defined. Okay, if I want to use my fancy math words, if the columns of the first matrix equals the number of rows of the second matrix, then the product is defined. Cool. But now the question is, what will be the dimensions of the actual product? So in this case, we're going to look at the outsides. Okay, the outsides will give us the dimensions of the product. So it's going to be 2 followed by 4. So altogether, the product should be a 2 by 4 matrix. So it's a matrix with 2 rows and 4 columns. So the question is, how do we actually multiply matrices? So we have a lot of guidelines, but I'd rather speak to you. Okay, so it says fun problem, find the product if defined. Oh, you know, if defined, what if it's a trick question? So let me before we start doing the hard math, let's see if the product is actually defined. So we'll start by listing the dimensions of each matrix. The first matrix has 2 rows, so it's going to be a 2 by something, and it has 1, 2, 3 columns, so it's a 2 by 3. Let's go ahead, list the dimensions of the second matrix. The second matrix has 1, 2, 3 columns, 3 rows, sorry, and it has 1, 2 columns. So the question is the product defined? And the answer is yes. Why? Because the insides are the same. If I want to use my proper math words, columns of the first equals rows of the second. And then the product, let's just call this matrix A, this matrix B, and the product will be dimensions of the outside. So it will be a 2 by 2 matrix. Okay, so when we get an answer, and then we should have that. So the question is, how does it go down? So this is how it's gonna work. We're gonna take the first row from the first matrix and then look at the first column of the second matrix. Okay, we are gonna multiply their entries and then find their sums. Okay, so it's gonna be like 1 times 3 plus the next product plus the next product. And the question is, where are we gonna put that in our matrix? Okay, in the product, because we have row 1 column 1, this will be in the 1 1 entry, so right there. Okay, so let's go ahead, do it together. Let's go ahead, multiply first row, first column. So we have 1 times 3. I'm kind of debating if I should show my work or go straight to the punchline. I'm gonna write the simplified products. Okay, 1 times 3 is 3. Let's keep moving forward. Next product, 0 times -1 is 0. Again, we find the products and add them. So plus 0. Final product in that round will be 3 times 0, which is 0. Cool. So what are we gonna do? We're gonna take the same row and multiply it by the next column. I don't want to put too many highlighters all over the place, so let me bust out my special effects. Cool. Yeah, so I just chopped off with transparency. So we're going to continue looking at the same row. We're done with first column. let's go ahead and multiply it by the second column. Okay, so let's go ahead find their products and multiply the elements and then find their products. So we're gonna look at row 1 column 2, row 1 column 2. That will be the 1 2 entry. So I'm over here, row 1 column 2. Okay, so let's do this. First product, 1 times 2 is 2. Next product, 0 times -1 is 0. Again, we multiply, add. Final product, 3 times 3. 3 times 3 is 9. Okay, no more columns, so we're good. On to the next row. It would have been faster if I used my fingers, but I don't want to put markers on my fingers. Okay, so we're done with row 1. Let's go ahead, look at row 2. Sorry, I needed something to hold my transparency. So row 2, column 1. Okay, row 2, column 1, that will be the 2 1 entry. So right here, row 2, column 1. Let's take the products and add them up. Okay, first product, 1 times 3 is 3. Next product, 2 times -1 is -2. So plus -2, or you can just put -2. Final product, oh, this moved. Final product, 2 times 0 is 0. Okay, done with that row. Let's go ahead, done with that column. Let's go ahead, look at the next column. Oh, this kind of looks like the whiteboard in my classroom. All right, so let's go ahead, take that same row, multiply it by the next column. So we're in row 2, column 2. So that'll be the 2 2 entry. 2 2 entry. We'll be right here. Let's go ahead, take the products and add the results. First product, that will be 1 2. So 1 times 2 is 2. Next product, 2 times -1 is -2. Again, we multiply, add, and then final product, it's 2 times 3, which will give us 6. There are no more columns, so we're good. There are no more rows, so we're good. Okay, now let's look at our prediction. So our prediction said that the product should be of size 2 by 2, 2 rows and 2 columns. That's exactly what we have. Let's just take care of the arithmetic. The sum of 3, 0, 0. The sum of 3, 0, and 0 is 3. The sum of 2 and 9 is 11. And the sum of 3, -2, and 0 is, I believe, 1. And the sum of, oh, these cancel out. 2 plus -2 is 0, and that will give us 6. Fantastic. And I know you could do this in your head, but again, when you look at your notes and all you see is an answer, how helpful is it going to be? Right now you may be hot, but if you have a midterm like in 2, 3 weeks or maybe 4, then you will have like a lot of lecture in the back of your mind. Go ahead, look at problem B. So we have two matrices next to each other, so let's go ahead, multiply them. But I want to know, is the product defined? Okay, so let's see if the insides are the same. When I say insides, I'm looking at the dimensions. So again, proper math words. I want to know, are the columns of the first matrix the same as the number of rows of the second matrix? So the first one has 1 row with 3 columns, so it's going to be a 1 by 3 matrix. The second matrix has 3 rows and 1 column. So I want to know, is this product defined? I don't know. Are these insides the same? And the answer is yes. Okay, so now if the first matrix, we call it A, the second matrix, we call it B, what will be the size of the product? So the size, we look at the ends. Okay, maybe I should have done that over here. Okay, so we look at the ends, and the product should be of size 1 by 1. So it's a matrix with 1 row and 1 column. So let's do this. So we're gonna take our only row and multiply it by our only column. So I don't need my special effects. All right, let's do this. Multiply, add all the way. So -1 times 4 will give us -4, plus the next product. 0 times 2 is 0, plus the next product. 3 times 3 is 9. Okay, there are no more columns, so we're good. There are no more rows, so we're good. And the sum of -4, 9 is 5. So the product of these two matrices will give us the 1 by 1 matrix with element of 5. Fantastic. So I know you're excited. Let's go ahead do one more problem. Okay, bear with me. Okay, so let's go ahead and knock out these final two problems. In this case, we are going to combine addition with multiplication. So let's do this. So problem A, we are asked to find negative 2b plus AD if defined. Let's go ahead and write down these matrices. So we have negative 2 times matrix B. Let me go ahead and write matrix B first. So we have negative 3, 1, 2, 5. And we are asked to multiply it by negative 2, and then we're gonna add to it product of A and D. So A is given by by 2, negative 1, 3, 0, 4, 2, and then D is given by 3, negative 2, 0, negative 1, 1, 2. Perfect. So if we get into this column, it's okay. All right, so we are to multiply and then add, but I want to know, first of all, can I multiply, and then if I can I really add? So let's see if this sum is defined. So when we take a matrix and multiply it by a scalar or number, it's not going to change the dimensions. Okay, so we have 2 rows, 2 columns, so this is a 2 by 2 matrix. Let's see if this product is defined. So this has 2 rows and 3 columns, so this is a 2 by 3 matrix. Next matrix is 3 rows, 2 columns, so it's a 3 by 2 matrix. So first question I want to ask myself, is the product defined? I need to know if these inside numbers are the same, or like math words. I want to know if the columns of the first equals rows of the second, and they do. And then the product, what will be the dimensions of the product? It will be 2 by 2. Okay, so now ultimately, once we take our products, we want to add them. So I want to know, is the sum defined? We can only add or subtract matrices of the same size. So we have a 2 by 2 matrix here. We will have a 2 by 2 matrix here. The sizes or the dimensions are the same, so the sum is defined. Okay, so let's go ahead and begin the multiplication process. For the first multiplication, let's go ahead and multiply each element by negative 2. So we have negative 2 times negative 3, which will give us 6. Negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. And negative 2 times 5 is negative 10. Fantastic. So let's go ahead and add to it the next product, which we have already established that is defined. So remember, to multiply matrices, we're going to start by looking at the first row, look at the first column, and then multiply their entries and then add the results. Okay, so let's go ahead and look at this. Row 1, column 1, that will be the 1, 1 entry in our product. Okay, so first product, 2 times 3 is 6. Next product, negative 1 times 0 is 0. So we multiply, add, multiply, add. Next product will be 3, 1. So 3 times 1 are 3. Cool. So we're done with this column. On to the next column. So same row, new column. Row 1, column 2, that will be the 1, 2 entry. So 1, 2 entry. So let's go ahead and multiply, add until we have no more. 2 times negative 2 is negative 4. Plus next product. Negative 1 times negative 1 is 1. Plus next product. 3 times 2 is 6. We're good. No more columns, so we're done with row 1. Thank you. Row 2, you're up next. Row 2, column 1, that'll be the 2, 1 entry. So 2, 1 entry right here. First product. 0 times 3 is 0. Plus the next product. 4 times 0 is 0. Oh, lucky us. Plus the next product. 2 times 1 is 2. That's it. We're done. So thank you. Column 1 on to column 2. Row 2, column 2, that will be the 2, 2 entry. 2, 2 entry. Let's do this. First product. 0 times negative 2 is 0. Plus the next product. 4 times negative 1 is negative 4. Plus the next product. 2 times 2 is 4. No more columns, no more rows. That's it. Okay, we're done. Let's go ahead, simplify this sum. This product. 6 plus 0 plus 3 will give us 6. Negative 4 plus 1, that's a lot for me. 1 plus 6 is 7, and 7 minus 4 is 3. Cool. Next row, that will be 2. 0 plus 0 plus 2 is 2. Next one will give us 0. Okay, so the product, thanks to our hard work, gives us 6320. And then the first matrix is given by 6, negative 2, negative 4, negative 10. We had already established that the sum is defined. You know, the sum will be defined because the matrices will be of the same size or same dimensions. We got a 2 by 2, 2 by 2, 2 by 2, 2 by 2. Sorry, my accent gets in the way. Let's go ahead, add entry wise. 6 plus 6 will give us, 6 plus 6 will give us 12. Negative 2 plus 3 is 1. Next row. Negative 4 plus 2 is negative 2. And negative 10 plus 0 will give us negative 10. Fantastic. So hopefully I don't have any technical difficulties. If I do, then I'll tell you in a bit. Cool. So let's go ahead, box our answers. Problem B. Okay, so problem B would be nice if you can see it. So problem B reads, find negative 2BA plus 6CD if defined. Okay, so I don't think I have space over here, so let me write it. So we have find negative 2BA plus 6CD if defined. Okay, so you're just gonna have to trust me on the matrices. So we have negative 2 times matrix B times A. So B is negative 3, 1, 2, 5. A is 2, negative 1, 3, 0, 4, negative 2. And we want to add to it, 6 times CD. So C is negative 1, 0, 2, 4, negative 3, 1, negative 2, 3, 5. And then D, you're going to just trust me that I'm copying this right. 3, negative 2, 0, negative 1, and 1, 2. Fantastic. So in this problem, we are asked to multiply the matrices. Well, the first product multiply, and then multiply the product by negative 2. Find the next product and then multiply it by 6, and then we'll add our results. But let's see, first of all, let's see if the products are defined, and then if so, let's see if the sum is defined. Okay, so the first matrix is of size, 2 rows, 2 columns, so it's a size 2 by 2. Right now we want to see if this product BA is defined. The next one is 2 rows, 3 columns, so is this product defined? It sure is, because the insides are the same. Or using my math words, columns of the first equals rows of the second. So the product, it will be, we look at the ends, the product will be a size 2 by 3. Cool. So let's go ahead, see if this, so we have a good start. Let's see if this product is defined. Okay, so the dimensions of the first matrix, 3 rows, so that'll be 3 by something, 3 columns, 3 by 3, and the next one is 3 rows and 2 columns. So yes, to answer the question, is this product defined? It sure is, because the insides are the same. Columns of the first equals rows of the second. So the product, what will be the dimensions? We're gonna look at the outsides. Okay, the outsides are 3 by 2. So cool. So we know that each product is defined, but now the question is, after we do all that hard work, will we be able to find the sum of the matrices? And the answer is no. Why? Because matrix addition and subtraction, we can only add or subtract if the sizes are the same. So in this case, the sizes are, let me just put size or dimension, are not the same. So to answer the question says find this if defined, and the sum is not defined. So the question is, we know that the sum is not defined, but do we have to simplify the products first and then make that call? You know what? That's really a personal choice. For me, if you took the time to just see if it's gonna be possible to do, I would totally give you full credit. Okay, if you were like, nah, I didn't do that, I just multiplied, and then realized I couldn't add at the end, that's fine too. It's really a personal choice. So yeah, so the question says find this if defined. It's not happening, so the sum is not defined, or you can just put not defined. It's up to you. Okay guys, that's my time. Thanks.